Hi, and welcome to this module about mappings and XSLT. So in this part, we'll talk about how you can actually transform mappings and what they're about. So if we look at the different mappings, there's three different operations under the mapping part. There's operation mapping, which is, I guess, a term mostly coming from the PI system. And in the PI system, you could you need to create an operation mapping, and then you can assign all the different components for that one. And that was because in the PI world, you needed to pipeline all messages together in one flow, and you didn't have the luxury as we have in CPI to concatenate and just add different flows depending on what we're doing. So there you had to make an operation mapping for each of the different operations you wanted to execute. And they could contain message mappings, XSLTs, and Java, and you can then mix between them. Most of the time, obviously, there would just be one operation mapping and one message mapping or XSLT. But in some occasions, and if you wanted extra monitoring, support, and stuff like that, it would be a useful thing to have either Java mapping in front that did some generic validation and moved it. I would say that it does not make as much sense in a CPI world because, well, it's not as flexible. CPI is more flexible, so you can just add all the different components as you want instead of having to, use this fixed structure with the data. I think if you're migrating some mappings, it makes sense. If you are just trying to figure out how this works, I would not recommend it. But just go for the message mapping, the XSLT, or the Groovy mapping as separate elements. I'm not sure on how the Java mappings would be migrated, but I would imagine that should be possible because you can also migrate message mappings, which is using the same interface. So the next one, and I guess this one makes a lot more sense, is how you can actually use a message mapping. So message mapping was one of the key functionality of the old XI3 system, and that was what people wanted to use to create new documents and the mapping editor there. And the purpose or the reasoning is that you create a structure and then you just fill in the data into that structure. So it is pretty easy to make at least create the initial ones. It becomes a lot more difficult once you want to understand the cues and the context in this one, which is a pretty advanced concept that covers how you can actually make the real structure good structure. So you need to understand that. I do have a separate training on all of this that you can attend based on the PI system, because it's a lot more required, whereas here it's the system is more flexible, so you probably will not end up creating as many message mappings and not for the complexity that we have seen here. It's pretty simple. You just need to create a schema for it, and then you're good to go. You can upload this, so it can either be schemas or XSDs or vistals that you upload, and based on this, you can create the mappings. I would say that it's a little more difficult to use, at least at the current iteration, than you have at this than what you saw at the swing tool, if you're familiar with that. So sometimes it's easier to do it in the swing tool, at least if you have been trained and been using that for a while. Then this one is, take a little while getting used to and be productive, and maybe it will be improved. So let's create our first mapping. So we'll go into our flow. And then we will create a new message mapping, And I guess we are on module 8, so I don't think I have created one for module 8. So that should be okay. No, there's actually one here. And we want to create a new message mapping on this. So we already have a flow here. We will start on this discard. Just check what we are normally doing. Figure that one out. So we will just, so we are here, and then we want to create a new message mapping. And the way we can do this is just, so here we got the operation mapping that you probably will not use. You got the message mapping and the XSLT. So we'll take the message mapping. We can then see, okay, there's no one here, and we cannot select any. Then we can create a new one, and we will then call this orders. Orders mapping. And now we need to add a structure to this. So I've created an XSD for this. So here we have, and I'll just use the same one for the output. And then we just have to do a mapping between these. We do have here a map one-to-one that will just take the same element in the new one. So we can upload a sample file, and then we can click here, display queue. It will then run this specific instance and get the values for this. So I guess it's not that interesting to work here with this, since we're just doing it really simple. So we also have the other approach, which is to simulate. So here we can see all the values. We have in our document 2 lines, and we can then run the test. And we can see obviously the data is converted as we want. We cannot download it. So let's try just to instead of taking the value from here, we want to count how many lines we have. And obviously there's a lot of ways you can do that. And so we just want to delete here. So we'll delete the mapping. So we will take it from, for instance, this one, map it here. Then we need to do this statistic variable here that counts, or the summarize. We don't want to summarize here, we just want to count how many entries we have. So we'll take the value from here and put it in here. And if we just run this now, it will be wrong, but I guess it'll just give you an idea about how queues and context works. So what I would expect is that we will get the first line, then we would get a context change, and that means that this one should then go to the next item and fill it in the output structure. So we will then actually, if we ran this now, it will just give us 1, and that would not really work because we want to have 2 in as the count of these 2. So what we need to do is we need to change the context of this one up to the root element, and if we do that and run this again, then we should be able to see that we don't have our context changed in here, and we are then getting our value 2 out here. So that was okay. We got the information that we needed, and we're good with that. So on our line item total, so one thing here is we have a price here, and I'm not sure if the price is calculated correctly. So I want the price to be equal to amount times price. So what we will do is just drag these 2 in. We will then do an arithmetic multiply these 2 numbers. And and there's under the rhythmic we also have one that is called format number, which is pretty important, otherwise you may end up with some strange values into it. So here we'll just say that it should be in a format that looks like this. We have decimal as comma, as period. So let's see how this would work out. So if we just take a look at our cues from this one, we can then see it takes 3 multiplied by 51. That's probably okay, and also here. So it's actually able to calculate these values. So now it would obviously be good if we could actually summarize this into our total instead of just using the value that we're getting. And the way we can do that is under here there's node function. The node functions allow you to make changes in these values that we already have. So you can do here, and then we will want to do a summarize. Statistics summarize. Sum here. So let's just take a look at these cues we have here. So if you look at this one, this would be the same output as we got from the previous one. But it will then remove the context that we have, and we can then see that we get a value here of two elements here. And if we looked at this one, we will also get display Q. We will then see the value out here. So let's just try to run this. Oh, we have saved it. Simulate. Hopefully I didn't. So let's see if it works. Yeah, we can see here we have not filled in the price of this one, and neither for this one, and the total is also completely wrong. So we can see we now got a price and a quantity, and we got a total. So all of these things work out as we would expect them to do. We also have functions like order date. If we want to create, so there's one here for order that can take the current date, and we can transform the date field. So we'll just use this one. We could use number range for the order number, but obviously you want to get this from the input document because that's where it will be better. If you wanted to add an extra line item, for instance with the packaging, you have the option here to say here duplicate subtree. I would not imagine that this should be. I would have moved it after here if it was to me, and then you can actually in this one map with a constant, map an item that with a constant 99, and then we'll just item packaging. Just okay. So this will be a way that you can actually get extra information into your document. And sometimes you would put in qualifiers that says if something is true, you'd use this one, or otherwise you'd use this one. So let's see. So now we can see, even though the structure and the mapping looks different, it is actually adding our line item the correct place. And we are getting our packaging in as we would expect it to. So this seems to be working. We can save it. We can run it if we want to, and it should work out pretty good. Then we also have the option that sometimes some of the things that you're doing is not really optimal, and you need to create a Groovy script for it that contains a user-defined function that does something specific. So it could be that you wanted to get the next date. You want to get one of the value from the dynamic attributes not dynamic attribute, from the header or the property of the payload. you wanted to get, yeah. So that is what is in the user-defined function. Something you can want to calculate if you want to do a hash of specific values. You can also get it from here. So let's just try to enhance this one. So we'll take this. We'll open our methods mapping. Let's save as a version first. So we'll go into edit, processing, and let's just try to see here for order number. So we have up here function create and assign. So assign is if you already have a Groovy script, you can upload it. So we'll just create a new Groovy script with some custom functions, and we can see here it's then adding some standard values for this. And here you can see how do we actually get the header information. How do we get, yeah, so there's two ways to define this. Either you can define it as a standard, a simple string, where you're just saying the output is a string, and then it will just concatenate two values. Or you can specify that the input is an queue, and then you would actually get the structure like this, and then you need to iterate over the array to process the data as you want it to. Let's just do the simple one. So let's just say, create a custom function. So you can just copy this one also if you wanted to create one. I'm not sure if that one would work. So here we're adding two output values. Probably not ideal. I'll just for this. Oh, let's see. So now we can see we're getting the data in here if we're adding this one. So now custom function to our order number. If we run it, oh, we need to upload again, obviously. That's one of the things that I'm missing, that in the old PI world you could save this and look at some of the different ones you have saved. So we can see that the user-defined function have now been executed. We have added some extra information, and as you saw in some of the template, you could see what we can do in it. And here we have it. Here we have the scripts and how it looks like. And I think if we're looking here in the resources of the iFlow, we can see we got a message mapping, we got our schema, and we got our scripts here. So this is just a plain old Groovy script that, so it would actually be able to reuse some of the same functionality across these platforms. So the next thing on this is testing and queue. We saw this, and if you're working with headers and properties, it's a little challenging to do testing of it because you cannot test it. So you would need to put in something in the Groovy script that says, hey, if you're testing this and you don't find this value, then assign some input value. And I also saw that you need, in PI world, you don't need to specify an input. In this one, you need to specify an input parameter for the message. Otherwise, it doesn't understand that. You need to have an XSD for this to work. And if you don't have an XSD, there's an online tool, for instance, like this one, where you can take your So I have my schema here. I can generate a Vistal. You probably want to edit some of these things if they're not correct. Short int, maybe not ideal. Byte, you probably don't want to go with that one either. But normally message mappings are not that picky about the type. I haven't seen really how much they have added or validation of these things. But obviously, if you're adding a validation afterwards, it's probably a good idea that you would use string or a better description of what this float that this one probably will be. But this is a way you can generate it. There's also a lot of other tools. But what I like with this is just an online one. Makes it easy to understand what's going on. XSLT is also a pretty powerful one. In the old PI world, it was a little complicated to use it. It didn't support the latest XSLT, so you only had version 1 unless you installed some extra packages. So it wasn't used that much in general. Obviously, some places you probably would use it more. But in a CPI context, I see it as a lot more powerful, and it gives you a lot more idea about how you can actually handle data. I think it supports the latest version 3 in CPI. I saw some release information that was added to it. But definitely it supports version 2, which is pretty powerful and give you some functions to understand moving back and forth in it. So you would be able to use XPath 2.0, and in here you have a lot of functionalities for listing elements and steps and handling different logistic information. You can also access a payload in it. I thought that was pretty interesting. So if we have a document like this, we can obviously specify values for it. Here they have added a Groovy Script that extract these values and use it in a function. And here we're just showing it in raw XSLT. So here just have a parameter that's called exchange. And then apparently on this it has some CPI or HCI header under the IT, where you can get header property and set header property, which is really useful for getting that into your mapping. So if you have tomorrow's date, you can actually use it in an XSLT. There's 2 ways to create an XSLT. So one, as we have here, just say user. If user equals true, then go get the given name and add it to a specific field. Take these other fields from somewhere else, and then you're actually just creating a document that looks like person, and then underneath for each employee you would have a person that's true, or a person with these information. And obviously it needs to be XML, so you need to end these as they're supposed to be. So that is one approach for it. The other approach is, as we have here, where we are matching with different templates, and we can do different things with templates. So when, for instance, if we're running with the same order, we have the option of creating an XSL. Let me just show you how to actually create this. So here we have our CPI, so we'll just create a new XSLT, or if you search for XSL, here it will just show this one. If you go the next step, it will show you can use these different functionalities. Let me just copy this one. So what it will do is it will check if I match order, it will create an order, and then apply templates would actually mean it should copy this value. So in here you can run the data with, here say run as XSL transformation. I have this one opened in my open files. It's not in my workspace. Let's see if open files works. Workspace, file system, file system. Oh. That seems a bit strange. So we can see it has been moved, but I guess it has found some strange XSLT. Let's try again. So run as XSL transformation, open files. I guess that's a problem. Sometimes it finds that you are using a wrong XSLT for some of the data, and that's one of the problems I do have with it. So let's try it the other way around. So if you run from here, run as... Oh, okay, let's just move this one into the folder. So we have module 8 sample file here. We will try to run it. Run as XSLT transformation, add files. We got our module 8 XSLT here. And we can see it has now been changed. It has new order number in the beginning, and it's just using the same data as we have here. So we could then actually upload it to the same flow. So here we have our flow. Say OK here. We can create our XSLT mapping, add it. We don't want to create it from here. We could, but I prefer to use the upload functionality, because then you would you have the option to find the right data, and obviously it's located in a different folder, so we just need to get this so now we should be able to run this, and we should get an input where the information has been transformed. Which would get a new output. So let's just try to deploy it. Let's see what I did here. Let's use this one. Body. Here we need to insert the sample body. Application XML. Send. And we can see we're now getting data back from both, which was pretty lucky. So we're getting data back from both instances. So we're both getting the new number that it's edited. So that was from the XSLT that we're adding it as a new number, and we're getting the count and the packaging information. So that showed you how these things worked, what you can do with it. If you want to do more with mappings, then I strongly encourage you. I do also have message mapping course that will actually teach you a lot more about these things, more on the XSLT side, but from a PI perspective. So check out that course on the main page. You can see a lot more about what you can actually do with the message mapping. So thanks for watching.